Alright, 3.3, quadratic functions and their properties. Alright, definition. Alright, a quadratic function is a function of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0. The domain of a quadratic function is the set of all real numbers. That means that anytime you have a quadratic function, already you know the domain is all real numbers, negative infinity to infinity. Okay, in order to graph a quadratic function, what you need to do is you need to put it in vertex form. So we're going to start by completing the square. We've got y equals 2x squared plus 8x plus 5. When you complete the square, actually, first thing I'm going to pull out a 2. And I'm going to leave the 5 outside the parentheses, so I don't have to pull out a 2 from the 5. My b term is 4. So I've got b over 2 squared, which is 4 over 2 squared. 2 squared is 4. So I'm going to add 4 and subtract 4. Now, in order to take out the negative 4 from the parentheses, I need to make sure I multiply it by 2, because this 2 is being multiplied to everything inside the parentheses. So to take it out of the parentheses, I'm going to make it an 8, or a negative 8 rather. Alright, negative 8 plus 5. Okay. This is a perfect square. Before I squared it, 4 was a 2. The 4 was a 2. So I've got x plus 2 squared. Alright. So now when we graph this, it's going to move down 3. And it's going to move to the left 2. So there's the vertex. And it's being multiplied by 2, so I'm going to go up 2 over 1. And this way also, because it's symmetric. There we go. Okay, the vertex is negative 2, negative 3, the axis of symmetry. Is this here? Okay, that's x equals negative 2. Alright, I'll let you guys do this one. Okay, now, I'm going to show you guys the proof of converting standard form into vertex form. Standard form, you guys already know, is f of x equals ax squared plus bx plus c. Okay. In order to convert it to vertex form, first thing you need to do is pull out the a. You can either leave the c inside or keep it outside. I'm going to keep it outside for this. Now, b over 2 squared, in this case our b is b over a. This is the same as b over 2a squared, which is b squared over 4a squared. So I'm going to add that and subtract that. Okay, and in order to take it out of the parentheses, you need to make sure you multiply it by a. Okay, this a cancels out one of these a's. So now I've got a And I'm also going to factor this. This is whatever it was before you squared it. Okay. Minus. Okay. Now, I'm going to get a common denominator. Okay. Okay, I'm actually going to put the 4AC out in front so that I can make this a positive. So I've got 4, gosh, I don't know why there's a delay, 4AC minus B squared all over 4A. Okay? Alright, so this is in vertex form. Hopefully you guys remember vertex form. F of x equals a times x minus h squared plus k. And as you can see here, according to this formula, h is b over 2a. I'm actually going to make a change here. Technically it's minus h, so this is a minus negative. Okay. Minus b over 2a, and k is 4ac minus b squared over 4a. Okay? So, if you ever hit a situation where you really don't want to complete the square and do all this, you could instead just memorize these formulas and plug it in here. Okay? Alright. Properties of the graph of a quadratic equation. Okay. Alright, this is just reiterating everything we just proved. F of x equals ax squared plus bx plus c. This is standard form. As we showed up here with our h, the vertex is going to be negative b over 2a, and then the y is whatever y is when you plug in the x term. The axis of symmetry is your x term at the vertex. If a is positive, the parabola opens up and the vertex is a minimum. Vertex would be down here. If a is negative, then the parabola opens down and the vertex is a maximum. Alright, so for example, without graphing, locate the vertex and the axis of symmetry. Obviously, because it's negative, it opens down. Okay? So, to find the vertex, what we need to do is we just need to plug it into this equation. So our h is negative b over 2a, which in this case is going to be, let's see here, negative 6 over 2 times negative 3. So we've got negative 6 over negative 6, which gives us 1. Alright, and then when we plug in 1 into this equation, we've got negative 3 plus 6 plus 1, which gives us 4. So the vertex is 1, 4. Axis of symmetry x equals 1. Okay, the x-intercepts of a quadratic equation. If you guys remember, the discriminant is that part of the quadratic formula that is under the radical. If the discriminant is positive, there's two solutions. If the discriminant is negative, there's no real solutions. And if the discriminant equals 0, there's one solution. Okay. Alright, example 3. Graph this function using its properties. Determine the domain and range of f. Determine where f is increasing and where it's decreasing. Okay. We already know from before that it opens down. The vertex is 1, 4, and the axis of symmetry is x equals 1. So let's just graph it. The vertex is 1, 4. Okay. There's the axis of symmetry, and it opens down. There we go. Now, it is increasing from negative infinity all the way up to 1, and decreasing from 1 to infinity. So I'm going to write that down. There we go. Alright, you guys can try this one. Let's go on to example 4. Alright, example 4. Do the following. Graph this by determining whether the graph opens up or down, finding its vertex and axis of symmetry. Alright, so we know that A is 1, B is negative 6, and C is 9. So this time, rather than completing the square and all that, I'm just going to plug it into the formula. We know that H is negative B over 2A. Which is negative 6 over 2 times 1, which gives us 3, positive 3. When you plug in 3, you end up with 3 squared minus 6 times 3 plus 9, which gives us 0. Okay, so 3, 0 is the vertex, and the axis of symmetry is x equals 3. We know that it opens up. So let's go ahead and graph it. So 3, 0. There we go. Alright. Determine the domain and range. The domain, hopefully you guys can see, is all real numbers. Any quadratic, the domain is always going to be all real numbers. The range is from 0 to infinity. Okay, determine where f is increasing and decreasing. It is increasing from 3 to infinity, and decreasing from negative infinity to 3. Alright, so this should say example 5. Whoops. But that's alright. I think I'm going to save this one for part B. Okay, so I'll stop it here.